This is The Scientific Method by Mr. Glenn.
Learning in science is fun. We can do experiments to help us solve problems, but without using an organized process, our results may not be correct. In order to make sure that our experiments are based on science, we must follow the steps of the scientific method. While we go through each of the steps, follow along and conduct an experiment of your own. The steps of the scientific method are: 1. Ask a question. 2. Gather information. 3. Make a hypothesis. 4. Test your hypothesis. 5. Analyze results. And 6. Draw conclusions. Let's take a look at each of the steps in detail. As you follow along, take out a piece of paper or open up a document on your device and begin taking notes and recording each step. This is very important. In step number 1, we must select a problem that we would like to find a solution to, or a question that needs answering. To demonstrate the steps using a simple experiment, we are going to investigate which type of paper airplane design is the best. Since there are many different types of airplane designs, we must first decide what we would like to test. We could choose the length of the plane, the weight of the plane, the style of the plane, or many others. Let's choose the length of the plane. We can define best airplane design as which one will fly the farthest. Now that we have an idea, we must first ask a question. Pause the video now and come up with a question on your own. Have you come up with a question? Great! For our experiment, we will ask the question, which length of paper airplane will fly the farthest? Don't forget to write this down. As we design our experiment, we must write out a plan. This is also known as a procedure. When doing experiments, scientists must choose one thing they would like to change, things they would like to keep the same, and what they will measure. By only changing one thing at a time during an experiment, scientists can be sure that the result was caused by the thing they changed and nothing else. So you can answer the following questions and add them to your design. What will I change? What will I keep the same? What will I measure? For our experiment, we will change the length of the plane. We have chosen to use paper airplanes with lengths of 20 centimeters, 25 centimeters, and 30 centimeters. We will keep the type of paper and the way we throw it the same, and we will measure the distance the planes fly. Before we move on, we will need to make a list of materials that we will need for our experiment. We are going to need paper, scissors, and measuring tape. Now that we have our research question, we must begin to learn all we can about paper airplanes. This step can help us with our experiment because we can learn information that other scientists have already learned by using the scientific method. Pause the video once again and take a few minutes to search for information about paper airplanes. You can use the internet for your search. For step 3, we must state a hypothesis. What is a hypothesis, you ask? Before we conduct our experiment, we can make an educated guess about what we think is going to happen or what our results will be. That guess is called a hypothesis. Based on the question we came up with in step 1, which length of paper airplane will fly the farthest, we must state a hypothesis that describes which length we think will fly the greatest distance and why. Once again, take a moment and pause the video while you come up with your hypothesis. Use the information you learned in step 2 to help you. For our experiment, we will state that we think the plane with the longest length will fly the greatest distance. Based on our research, we determined that length of airplane may help with stability in flight, which we think will allow it to fly the greatest distance. So our hypothesis is, we think the 30 centimeter plane will fly the farthest. Make sure to write yours down. Now that we have our plan and our hypothesis, we are ready for testing. To make sure we have accurate results, we must conduct our experiment several times. We will conduct our experiment 3 times and record the average distance each airplane flies. In order to make collecting our data easier, let's create a data table. Your table should include the thing you will change, the length of the airplane, and what you are measuring, the distance traveled. Always include units when you enter your data. Your table should look something like this. Now that you have your table, build your airplanes according to the lengths that we decided on earlier. Make sure you throw each airplane in the same way. Throw each airplane 3 times and record the results right away so you don't forget. When you are done, calculate the average distance each airplane flies. Now that we have collected some data from our experiment, we can begin to make sense of it. Finding patterns and relationships in data is how we can determine what our data really means. Using graphs is a great way to analyze data, and it helps paint a clear picture of our results. Since we are comparing the results of 3 different paper airplanes, let's use a bar graph to show our data. To create a bar graph, we can use graphing paper. Remember, the x-axis runs from left to right, and the y-axis runs up and down. We must put the thing we changed on the x-axis and the thing we are measuring on the y-axis. Make a bar graph like this and fill it in with your results. Make a bar graph that looks like this one and fill it in with your results. Here's how ours looks. Does yours look similar? Now that we have analyzed our results, we must draw a conclusion. We can use our bar graph to describe what happened. When we look at our bar graph, we can see that as the length of the airplane increased, the distance the airplane flew also increased. So, we can say that the best airplane design was the longest one. This means that a longer airplane design will fly farther than a short one. Now we can look back and see if our hypothesis was correct. As we look back, we can see that our hypothesis was, we think that the 30-centimeter airplane will fly the farthest. Looking at our results, we can see that our hypothesis was correct. Great job! Sometimes our hypothesis is incorrect, and that's okay too. We don't always have the answers when we make our predictions, but science helps us find them. So that's it. We have officially conducted a science experiment using the scientific method. Wasn't that easy? Don't forget to share your results with others so that they can learn too. Now, make sure you write out a complete report. Find someone to take a look at it for you and see how you did. If you completed this exercise in class, submit your report to your teacher or a peer for grading. Thanks for watching, and make sure to always follow the steps of the scientific method.